Dear students, we will now discuss the Ford Fulkerson method, the method to find the maximum flow in a flow network. The Ford Fulkerson method is based on three important concepts, namely the residual networks, augmenting paths, and the graph cuts. This method iteratively increases the value of the flow. It initially starts with the flow value of 0 for all the edges and gives an initial flow of starting with an initial flow of 0. At each iteration, the method increases the flow in the flow network G by finding an augmenting path in an associated residual network GF. During the increase of flow, some of the edges may have increased flow and others may also have a decreased flow. The outline Ford Fulkerson method goes like this. Initialize flow F to 0. While there exists an augmenting path P in the residual network GF, you go on augmenting flow F along the path P. Once you come out of the while loop, you return the flow F and that will be the maximum flow possible. In order to implement this, we need to introduce several additional concepts such as the residual network, augmenting path, and the graph cuts. What are residual networks then? Given a flow network G and a flow F, the residual network GF consists of edges with capacities indicating by how much we can change the flow on these edges of G. We define the residual capacity of an edge in a residual network for every edge in a flow network as Cf of u, v is equal to C of u, v minus F of u, v, where C depicts the capacity of the flow network edge UV and F of UV represents the flow in that edge UV. Residual networks also have edges with no corresponding edge in the flow network and its capacity is Cf of Vu is equal to F of u, v. In the residual network there is a edge V, u but there is no corresponding edge V, u in the flow network. But the value of the capacity is F of UV, there is a flow in the reverse direction. Formally, we define the residual network capacity as follows. For a given graph G is equal to V, with a source S and a sink T and a flow F, the residual capacity of edges in the residual graphs there is the residual network graph is as below. Cf of u, v is C of u, v minus F of u, v if the edge UV exists in the flow network E. Cf of u, v is equal to F of v, u if the edge Vu exists in E and it is 0 otherwise. Because in a flow network, if UV belongs to E, Vu will not exist. Only one of the above three cases will be true for any given edge UV. Further, given a flow network G and a flow F, the residual network of G induced by F is GF is equal to V, EF, where EF consists of those edges U, V where the capacity Cf of UV is greater than 0. The number of edges in EF is less than or equal to 2 times of E because it contains edges in E as well as edges not in E. A flow in a residual network GF is similar to a flow in a flow network with capacities given by CF. If F is a flow in G and F dash is a flow in the corresponding residual network GF, we define F augmentation F dash, the augmentation of flow F by F dash as follows. F augmentation F dash u, v is equal to F of u, v plus F dash of u, v minus F dash of v, u if UV belongs to E and it is 0 otherwise. Hence, an augmenting path P in a graph G is a simple path from S to T in the residual network GF. By definition of the residual network, we can increase the flow in an edge U, v of an augmenting path by up to Cf of u, v without violating the capacity constraint. Now the residual capacity of the augmenting path is computed as below. Cf of P, that is the residual capacity of the augmenting path P, is min of Cf of u, v for all UV is for all UV on path P. That is, let us assume there are 4 edges in a augmenting path P from S to T, and each of those 4 edges have different capacities. Now the capacity of the whole path will be equal to the minimum of the capacities of these 4 edges, and that is depicted by this mathematical equation. We will now take an example and try to understand the residual network and an augmenting path. The first graph here, depicted by 26.4a, depicts a flow network with the capacities as well as a flow. For example, the value written between S and V1, 11, 16, says that there is a flow of 11 in a capacity of 16. Similarly, S to V2, there is a flow of 8 and in a capacity of 13, and so on. The actual flow in this particular flow network is 11 plus 8, 19, that is going out of S, and that also terminates on T, that is 15 plus 4, that is 19. Now, according to the definition which we already discussed, we will construct the residual network for this flow graph. If you see here, the edge between S and V1 has a capacity of 5, that is 16 minus 11. We know that CF of U comma V is equal to C of UV minus F of UV, that is 16 minus 11, 5. And in the reverse direction, V1 of S is equal to whatever is the flow in the reverse direction. The flow is 11, hence V1 to S is 11. Similarly, we have constructed for all the edges, and the residual network has been shown in B. Now what we do is we find a simple path from S to T. One of that path is this, from S to V2, V2 to V3, and V3 to T. The capacity from S to V2 is 5, capacity from V2 to V3 is 4, and similarly the capacity from V3 to T is 5. The minimum of that is 4, so the augmenting path from S to T has a capacity of 4 only. That is, we can add a value of 4 to the existing flow. The existing flow, as you know, is 11 plus 8, that is 19. Now if you add a flow of 4, it should be 23. Now how do you construct that? That with addition of the augmenting path is given in the third graph, that is in C. So here there is no addition in the augmenting path, is not there between S and V1, so it remains 11 out of 16. But in the second one we are adding 4 because the capacity of the augmenting path is 4, so instead of 8 it has become 12. If you notice this, it was 8 here, now it has become 12. And now notice there was in augmenting path a value of 4 flowing from V2 to V3, but here there is no edge from V2 to V3, but there was a flow of, originally there was a flow of 4 from V3 to V2 in the figure A. Now as there is a reverse direction flow of 4, we can make it as an additional flow of 9 in the reverse direction, that is V3 to V2. There is a flow of now 9 going from V3 to V2. And additionally, if you see, the augmenting path had a value of 4 from V3 to T, and that gets added to the previous value of 15, it becomes 19. So notice from V3 to T it is 19 out of 20, and from V4 to T it is 4 out of 4. So 19 plus 4 is 23 going into T. Similarly, if you come going out of S, it is 11 plus 12, that is 23. So the total flow in this flow network is 23. For this, again we can construct a residual network for this particular flow. You can see this applying the same definitions. We have got the flow network in the figure D. Now, a more detailed Ford Fulkerson algorithm, Ford Fulkerson method for each edge UV belonging to G dot E. We make U comma V dot F is equal to 0. That is, we initialize the flow as 0. Now, while there exists a path P from S to T in the residual network GF, CF of P, that is the capacity of that particular path P, is minimum of CF of UV for all UV in the path, we find the minimum capacity. Next, what we do is for each edge UV in P, if UV belongs to E, we are going to increase that u comma v dot f is equal to u comma v dot f plus Cf of P. And if it is not there, else v comma u dot f is equal to v comma u dot f minus of Cf of P. So this is going to achieve what is the required thing as we have discussed in the previous figure. That is the basic Ford Fulkerson method. Now, some results which are important for the Ford Fulkerson method, I'll just highlight those things. The first one is, given a graph GVE, which is a flow network, and F be a flow in G, and P be an augmenting path in GF, we define a function f of P, Fp of V cross V to a real number, and that's equal to Cf of P if UV is on P and 0 otherwise. So what we do is, the additional flow will be capacity of that path, capacity of the path as we have defined already, and Fb is a flow in GF with value Fp is equal to Cf of P greater than 0. And this is going to be added to construct the additional flow or the augmented flow. The next result is, let G is equal to V comma E be a flow network and F be a flow in G, and let P be an augmenting path in GF. Let Fp be defined as in the above equation, and suppose that we augment F by Fp, then the function F augmentation Fp is a flow in G with the value F plus Fp, and it is greater than the previous flow. This is also an important thing which we will use in further proofs. Now, we define what is a cut in a flow network. A cut S comma T of a flow network G is equal to V comma E is a partition of the vertex set V into S and T is equal to V minus S, such that small s belongs to S and small t belongs to T. If F is a flow, then the net flow across the cut S comma T is defined as F of S comma T as summation of U belonging to S and V belonging to T, F of U comma V minus U belonging to S and V belonging to T, F of V comma U. The capacity of the cut ST is only the one-way direction, that is equal to C of S comma T summation U belonging to S and V belonging to T, C of U comma V. Now, a minimum cut of a network is a cut whose capacity is minimum over all the different cuts of a flow network. Notice the difference in when we define a flow, we consider the reverse flow also, but when we define the cut capacity, we consider only the forward flow capacities. Now, again we'll try to understand the cut through an example. In this graph, the vertices with black are in the set S and the vertices which are in white are in a set T. The vertices S, V1 and V2 are in set S. The vertices V3, V4 and T are in the set T. Now, if you see this, the capacity of the cut ST is 12 plus 14, that is 26 only, the forward flow. But if you consider the flow across the cut, it is 12 plus 11, 23 minus 4, that is 19. So that is what is being shown here. We have to understand the flow across a cut as well as the capacity of the cut. Thank you. We'll try to understand something more on the maximum flow and the max flow min cut theorem in the next video. If you have any questions, you can post it in the Google Classroom. I'll try to answer it, or else you can send a direct WhatsApp message to me also. I'll also answer that. Thank you once again.